Okay, let's dive in. So imagine you've got this huge spreadsheet, maybe, or even a whole database. Thousands, maybe millions of rows of data.
Yeah, employees, products, orders, customers. It's all in there.
Exactly. But you don't need all of it right now. Maybe you just need, say, the engineers who make over 70 grand.
And you want them listed highest salary first.
Right. How do you pull just that specific info out of the chaos?
That feeling of being swamped by data is so common, isn't it? I mean, having the data is one thing, but the real skill, the superpower, is getting exactly what you need quickly and presenting it clearly.
Absolutely. And that superpower, it really starts with nailing the basics of asking your data the right questions. So today, we're really digging into two fundamental SQL commands, where for filtering,
which is like telling the database, hey, I only want these specific rows.
Yeah, exactly. And then order by Y for sorting, arranging those rows just how you want them.
And we're pulling this from material that's designed to build these core skills. We'll use examples from those typical sample tables you mentioned. Employees, products.
Customers, orders.
Yeah.
Right? Make it feel real.
Yeah.
So our mission here is to boil this down, make it practical, show you how these two clauses are basically your essential toolkit for cutting through all that noise.
And getting organized, targeted answers from your data.
Okay, let's start with the first big piece then. Filtering. You've got your table, tons of rows, but you only want some of them. How do you, tell it your criteria?
That's exactly what where is for. It's your condition setter, like putting up a filter, basically.
Only show me rows that pass this test. Something like that.
Precisely. And the basic structure, it looks really simple. Select columns from table where condition. The where clause slots right in after you say which table you're looking at.
Okay, so simple example. Finding employees earning more than, say, $50,000.
Yep. That would be select from employees where salary $50,000.
And looking at our sample data, that would immediately cut out a couple of people, leaving you with John Smith, Mike Davis, David Wilson, Lisa Anderson.
Exactly. See, you're selecting all columns with the ZO, but the where clause is the bit restricting which rows you actually get back based on that salary condition.
Okay, so the condition itself is crucial. What kind of conditions can we use? I mean, I'm guessing the usual comparisons, like equals, not equals.
Oh, yeah. That's your basic toolkit for filtering. You've got for exact matches or sometimes for not equal to, and then your standard number comparisons. Greater than A, less than A, greater than or equal to, less than or equal to.
Right. Give us another quick example.
Right.
What if I only wanted people in one department, like just engineering?
Okay. You'd write where department engineering. And notice the quotes there because engineering is text.
Ah, good point. Quotes for text.
Yeah. And that would narrow it down to just John Smith, Mike Davis, and Lisa Anderson from our list.
And if I wanted everyone but engineering?
You just flip the operator. Where department Channer? Engineering.
Okay. And that gets you Sarah Johnson, Emily Brown, David Wilson.
Right. Or for numbers, like you said, where salary legal $50,000 would pull up Sarah Johnson, who's at $45K, and Emily Brown at $38K.
So these operators are really about saying match this, don't match this, or fall in this range.
That's the core of it, yeah.
But, I mean, real questions are often more complex, aren't they? You usually need to combine things, like find engineers, and they have to make over 70K.
Exactly. And that's where your logical operators come in, and, or, and not. They let you build much more sophisticated filters.
And D seems pretty clear. Both conditions must be true.
Correct. So where department engineering and salary $70,000 means a row only gets through if the employee is both in engineering and has a salary over $70K.
Okay.
In our sample data, that specific filter would only let John Smith, Mike Davis, and Lisa Anderson through.
And ORIA is different, right? That means just one of the conditions has to be true.
Precisely. So if you wrote where department HR or department marketing.
You get anyone from HR or anyone from marketing.
Yep. Emily Brown from HR would show up. Sarah Johnson from marketing would show up. They don't need to be in both. It usually expands your results rather than narrowing them like Andy.
Okay, that makes sense. Now, I've sometimes seen parentheses used in where clauses, especially complicated ones. How do they fit in?
Oh, yeah. Parentheses are all about controlling the order of operations. Just like in maths, really. Especially when you mix and OR.
Right.
So let's say you wanted employees earning over $70K, or anyone who works in either Chicago or Boston.
Right. Complex condition.
You'd write it like this. Where salary $70,000 or city, Chicago, or city, Boston. See the parentheses?
Around the city part.
They group those or conditions for the cities together. So the database understands it as find the high earners or find the people in Chicago or Boston.
I see. Without the parentheses, it might get confused about which or and D applies where.
Exactly. The logic could get mixed up. Parentheses make your intention clear.
Okay, so we've got basic comparisons, and, or, not for combining. Are there other handy tools for defining conditions? Any special operators?
Yes, definitely. There are a few really useful ones. Like is fantastic for pattern matching in text.
Pattern matching?
Yeah, using wildcards. The %% stands for, well, any sequence of characters 0 or more, and the underscore stands for any single character.
Okay, so how would you use that? Like finding names starting with M.
You'd write where name like M%. The M followed by the % means starts with M and can have anything after it.
Got it. So Mike Davis in our list.
Right. Or where name like % first would find names ending in son.
Like Wilson or Anderson?
Exactly. And maybe where name like O%. That looks for names where the second letter is O.
Ah, the underscore is just one character.
Yeah.
John Smith.
Perfect. It's really powerful for finding things when you don't know the exact spelling or you only know part of it.
Yeah, kind of fuzzy searching. What about in? That sounds like it could be a shortcut.
It is. In is great when you want to check if a column's value matches any value in a list you provide.
So instead of writing department engineering or department, sales or department, marketing.
Yeah.
Which gets long.
Right, exactly. You can just write where department in, engineering, sales, marketing. Much cleaner, much easier to read, especially if you have a long list of options.
Okay, I like that. Between seems pretty self-explanatory for ranges. Numbers or dates.
It is. Between checks if a value falls within a specific range. And importantly, it includes both the start and end values. It's inclusive.
Okay, inclusive.
So where salary between $40,000 and $80,000 gets everyone from $40K up to $80K, including anyone right on $40K or $80K.
And works for dates too, like finding people hired in 2021.
Yep. Where hire date between 2021 A01 and 2021 12/31. Perfect for date ranges.
Yeah.
Again, notice the quotes for the date values.
Got it. And the last one's is NOL and is not null. That's for missing data, right?
Correct. NLL in SQL means a value is missing or unknown. It's not the same as 0 or an empty text string. It's nothing. And you can't use equals or not equals with NL. You have to use is null or is not null.
So where city is not null would find everyone where we actually have a city listed for them.
Exactly. It filters out anyone with a missing city value.
Wow. Okay. Where gives you a ton of precision, really lets you pinpoint the exact rows you need. But once you've used where to get that filtered set, the results probably just come back in whatever order the database felt like giving them. Not necessarily useful order.
That's usually the case, yeah. They might be ordered by how they're stored physically or maybe seemingly random.
So how do you make them appear in a sequence that makes sense? Like alphabetical or highest to lowest?
That is exactly what the order by clause is for. It takes the results you got maybe after filtering with where, and it sorts those rows based on one or more columns that you tell it.
Okay, and the syntax looks like select columns from table where, condition order by column ASDES. So you list a column and then maybe ASC or DSC.
Right. ASC means ascending order. That's the default, actually.
Ah, okay. So if you just say order by name, it does AZ automatically.
Yep. Smallest to largest for numbers, A to Z for text, oldest to newest for dates. If you want the opposite, you explicitly add DAC for descending.
So select name, salary from employees, order by salary. Would list them starting with the lowest salary. Emily Brown at 38K.
Then Sarah Johnson at 45K and so on, up to Mike Davis at 82K.
And if I wanted highest salary first?
Just add DS. Order by salary DSC. That would start with Mike Davis, 82K, and go down to Emily Brown, 38K.
And for names, order by name, we just list them alphabetically. David Wilson, Emily Brown, John Smith.
Exactly. Very straightforward for sorting by one column.
But what if you need, like, a secondary sort? Sort by department first, then by salary within each department. Can you do that?
Oh, yeah. Very common requirement. And it's easy. You just list multiple columns in your order by clause, separated by commas.
Oh, okay.
The database sorts everything by the first column you list. Then, for any rows that have the same value in that first column...
Like all the engineers.
Exactly. For all the engineers, it then sorts them based on the second column you listed. And you can keep going with more columns if needed.
And can you mix ASC and DSC? Like, sort departments AZ, but salaries high to low within each?
Absolutely. You can specify ASC or DSC for each column independently. So that example you just gave.
Yeah.
Order by department ASC, salary DSC, or just order by department salary DSC, since ASC is the default for department.
Okay, so what would that look like? It sorts everyone by department first, engineering, then HR, then marketing, sales.
Alphabetically.
Then it looks inside the engineering group.
Yeah.
And sorts those people by salary, highest first.
Correct. So for engineering, you'd see Mike Davis, 82K, then Lisa Anderson, 78K, then John Smith, 75K.
Got it. Then it moves to the next department, say HR, finds Emily Brown, sorts her, well, just her. Then marketing, finds Sarah Johnson.
And sorts them by salary descending within their department group. That structure is super useful for creating grouped reports or ordered lists.
Definitely. Gives you that nice hierarchical structure.
Yeah.
So, okay. We have where to choose the rows, order by to arrange them. How do they actually work together in one query? Is there a strict order you have to write them in?
Yes, absolutely critical point here. Where always comes before order by. Always.
Always. No exceptions.
No exceptions. Think about it logically. You want to filter the data down first to get only the rows you care about.
Right, make the pile smaller.
Exactly. And then you sort that smaller, relevant pile of results using order by.
So you can't just sort the whole massive table first and then pick out the rows you want.
Nope. The database is optimized to process where first to reduce the amount of data it needs to handle for subsequent steps like sorting. It's much more efficient that way.
Okay, efficiency makes sense. So the structure is always select.
From table, where condition or.
Order by column.
That's the sequence.
Yeah.
From, then where, then order by.
Okay, let's revisit that first problem we talked about. Engineers making over $70 sorted highest salary first. How does that look now?
Okay, walk through it. We need employees.
From employees,
Filtered by department and salary.
where department engineering and salary 70,000.
And then sort the results.
Order by salary DESC.
Perfect. Put it all together.
Select name, salary from employees, where department engineering and salary 70,000. Order by salary DESC.
And that query would give you back exactly Mike Davis, 82K, Lisa Anderson, 78K, John Smith, 75K. Just those three in that order.
Nice. Or another one. Everyone making over $50, but sorted alphabetically by name.
Okay, so select name, department, salary from employees. Filter is where salary 50,000.
And sort is order by name.
Right. And that would give you David Wilson, John Smith, Lisa Anderson, Mike Davis. All over 50K, but now listed alphabetically.
See, combining them really gives you that precise control.
Yeah.
What you see and how it's arranged.
Yeah, it feels less like just grabbing data and more like sculpting it, you know?
Yeah, I like that. Sculpting the data. Okay, let's try a couple quick ones with those other sample tables, like products or customers, just to make sure the idea clicks everywhere.
Good idea.
What if I wanted to find all the electronics products that cost less than, say, $1,000?
Okay, so now you're looking at the products table. You want all columns, maybe. So select. The conditions are. Category has to be electronics, and the price has to be less than 1,000.
So select from products where category electronics and price 1,000.
You got it. And if we look at the sample product data, that query would return the wireless mouse, the smartphone, and the tablet.
But not the Laptop Pro.
Right, because even though it's electronics, its price is over 1,000. The A&D means both conditions have to pass.
Makes sense.
Okay.
Simpler one. Just get a list of all customer names, sorted alphabetically.
Okay, that's purely a sorting job on the customers table. You just need the name column.
Select name.
From the right table, from customers, and then sort by name, order by name.
So select name from customers, order by name. Pretty clean.
Yeah. No where clause needed if you want all the rows, just the
Fine.
order by why I'd arrange them. And you get Alice Cooper, Bob Martinez, Carol White, alphabetically.
Okay. Now, the source material also mentioned counting rows. You see count sometimes. How does that fit in with where and order by?
Ah, count. That's what we call an aggregate function. In its simplest form, it just counts how many rows are in the result set of your query.
So select count from orders.
Yeah.
You just tell me the total number of orders in that table.
Exactly. If there are 6 orders in the table, it just returns the number 6.
Can you use it with where? Like count only the sales employees.
Yep. Select count from employees, where department, sales. It counts the rows after the where filter has been applied, so it tells you the size of your filtered result set.
Okay, so it's a way to get a summary number.
Right. There's also count column name, which counts non-missing values in a specific column, and count distinct column name, which counts only the unique values. But count is your basic row counter.
Got it. Okay, as people start writing these queries, what are some common mistakes or tricky bits they run into?
Oh, the number one easily is getting the clause order wrong. Trying to put order by before where.
Which just doesn't work.
Nope, the database parser will complain. Where has to come first if you're using both.
And we mentioned it earlier, but forgetting the quotes around text values seems like a really easy typo.
It is. Where department engineering without quotes. The database thinks engineering is maybe a column name or some keyword. It doesn't know it's the value engineering you're looking for. Throws an error.
Right. Okay, so syntax details matter. What about making queries run fast, especially when you have, like, millions of rows? Any tips there?
Yeah, performance is definitely something to think about. A big one is being specific with your columns.
Instead of select S.
Exactly. Select is easy when you're exploring, but for actual applications or reports, listing the specific columns you need, select name, salary, hire date is almost always better.
Why is that?
Because the database only has to retrieve and potentially send less data. Less data movement means faster execution.
Okay, that makes sense. Less work.
Mm-hmm. And another really crucial thing for performance relates back to the where clause, the columns you filter on frequently.
Like department or employee, maybe.
Yeah, those are often really good candidates for having an index created on them.
An index. Like in the back of a book.
Kind of like that, yeah. It's a special data structure the database can use to find rows with specific values in that column much faster than just reading through the entire table from start to finish.
Ah, so if I often run queries like where, department sales, having an index on the department column would speed that up significantly.
Dramatically, often, especially on large tables. So your where clause isn't just about what data you get, it also hints at how the database can find that data efficiently if the right indexes exist.
Wow. Okay, so filter early with where, use specific columns, and think about indexes for columns you filter on a lot.
Those are key takeaways for performance. Filtering first is probably the biggest one. It reduces the amount of data that needs sorting or any other processing later on.
Filter first, sort second. Got it. Any other quick performance tips?
Well, if you only need, say, the top 10 highest salaries, don't pull back all salaries and sort them just to look at the first 10.
What should you do?
Use the limit keyword, or sometimes top, depending on the specific SQL database. Order by salary, DESC limit 10, tells the database you only want the top 10 after sorting. It can often optimize for that and be much faster.
Okay, limit for top end results. Good tip.
Yeah.
This is a really solid grounding in filtering and sorting. But, to really make it stick, people need to practice.
Absolutely. Theory is one thing, hands-on is key.
Was there a good challenge example in the source material that really combines where and order by? Something for listeners to try.
Yeah, there was a good one. It asks you to find employees who are in either the engineering or the sales department.
Okay, so an or condition.
Right. And they also have to earn more than $60,000.
So an AND combined with the OR probably needs parentheses.
Good thinking. And then once you have that list of people, you need to sort them. First, by department name, alphabetically.
Okay.
And then within each department, sort them alphabetically by their name.
Ooh, okay. That's a nice multi-step problem.
Yeah.
Uses where with or and AND, needs parentheses, and then a multi-column order by. That really tests if you've grasped how to put it all together.
It really does. And there was another interesting one, a bit harder maybe. Finding the top 2 most expensive products, but only within the electronics category.
Ah, okay. So you need where for the category, order by price descending.
Yep.
And then that limit thing to get just the top 2.
Exactly. And you'd probably only want to select the product name and price, not weight.
Right. Be specific. Those sound like great practice exercises. What's the best way to approach them?
I'd say start simple. Maybe get the where clause working first. Test that.
Okay.
Then try the order by separately on a larger set, just to see if it sorts how you expect. Then combine them. Use the sample data from the study guide. Play around, experiment. See what happens if you change AND to or switch the order of columns in order by.
Yeah, don't be afraid to break it and figure out why. Hands-on is the way.
It really is the best teacher for SQL.
Okay, so just to recap this deep dive then, we've really dug into the where clause. That's your tool for picking which rows you want.
Using all those operators, comparisons, AND, or, not, and the special ones like in between is NULL. Lots of tools in that toolbox.
And then we looked at order by why. That's how you arrange the rows you selected.
Putting them in ascending or descending order based on one column or even multiple columns for those hierarchical sorts.
And the absolute key takeaway on using them together.
Sequence matters. Where filters first, then order by sorts the filtered results. Always in that order in your query.
Mastering these two, where and order by, it really feels like the foundation for doing anything useful with data in SQL, doesn't it?
It absolutely is. It moves you from just looking at a big pile of data to actually being able to pull out specific, organized information that answers your questions.
Yeah, they're like the keys to unlocking targeted insights. Now, the material we looked at hinted that the next logical step in this SQL journey is understanding joins.
Oh, yes, joins. That's how you start connecting data from multiple related tables together, like connecting orders back to the customers who place them.
Right. That sounds like where things get even more powerful, but probably builds right on top of what we learned today.
Definitely. You'll still be filtering and sorting, but across data combined from several tables.
Okay, something to look forward to. But just focusing on today, think about the power you get from just these two clauses, where and order by. It seems simple, but it lets you take a huge, messy data set, slice out exactly the records you need, arrange them perfectly for whatever you're doing a report and analysis.
And suddenly find insights that were just lost in the noise before. You can find the top-performing salespeople or the products nearing their expiration date or customers in a specific region.
Right. They're not just commands. They're like tools for discovery.
Oh.
So the final thought maybe is, what specific answers, what insights are waiting for you in your data now that you know how to ask the database exactly what you need and get that answer back, neatly sorted?